My name is Narvaja. For most of you that can't pronounce it, I go by Gerry, and since it was a given nickname from my mother, it's okay, even though the names are in Spanish. And my Twitter handle is Seattle Gaucho. I'm originally from Argentina. I've been working with databases for more time than some of you have been born, and worked for MySQL for 7 years. And then worked as a MySQL DBA at a couple of other organizations, PTN, and right now with OpenMarket. So one of the things as a DBA that usually, as a MySQL DBA in particular, that is concerning is MySQL doesn't have much instrumentation, and although software like the MySQL Enterprise Manager sort of addresses that and presents graphics and neat advisors, and so does Monyo, most organizations already have in their, as part of their infrastructure, some monitoring software, network monitoring software that has been there for forever, and the SAs are very familiar with it. And what it does is collects all the SNMP variables and numbers and charts them. So why not do it for MySQL? So there was already, and it still exists, and it's actively developed, a MySQL SNMP agent. The problem is that it doesn't quite work with CentOS, CentOS 5, and that's why we did a fork of sorts, and since that actually doesn't fill a 40-minute talk, usually they don't last 40 minutes, my talks anyway. We also, what we did is, I'm going to illustrate how we introduce another variable that it's not in the original agent, and how simple it is if you know what you're looking for. And finally, I'm going to show a few charts that we got, and which will justify why we went through this effort. So, why SNMP? It's a widely known standard. It has been there forever. It's supported in a bunch of open source tools like OpenNMS, Nagios, Cacti, and some commercial ones very well known in bigger installations like OpenView, Unicenter, and many more. Why use pass persist instead of agent X or the sub-agent that the original agent does? Well, it's a very simple protocol. What it does is it requires a pipe where you get something, you provide something through standard input, and everything is printed on standard output. So it makes it extremely easy to diagnose the script, because you can run it interactively from the Linux shell, and you can test all the values. You don't have to go through all the SNMP protocol, which of course it also works, but when you're trying to find out why some values or some charts are not being populated, it's a lot easier to just go in, launch the script, type a few things on your keyword, and then see what comes out. The original MySQL SNMP agent and our data gathering code is actually derived from it, is on that URL. The URL doesn't render, but when I publish, when you see the presentation online, the URL is live. And it uses the NetSNMP sub-agent, as I said before, which is broken in CentOS 5, which is the one of the most widely platforms out there. So you would have to either install on CentOS or Red Hat 5 the latest and greatest, which is not always easy, especially when you have hundreds of servers and you need to, and that agent is actually also collecting information from other services that are adjusted to it, so it's not always possible. So why number 2? Well, as I explained, pass persist is a lot easier. And we also, the original project is managed by one person, and although I reported all the bugs and eventually they got fixed, we needed the solution running right now. The original agent was written for, I can't remember whether it was 5.1 or 5.0, And the show INNODB status, actually some of the variables, the output is different, so the parser doesn't work that well. So we had to fix those. Both the original author of the tool and ourselves, we don't have that much time to make it generic for 4.1 and even 5.5. We haven't looked into that yet. So we needed to something like any other open source user, something that we could fix and patch ourselves. And we also added our own functionality, which is the bytes behind master. So in order to use the old code, one of the things we had to do is actually we got the original agent and made it into a Perl module. I haven't mentioned this yet, but it's all Perl. Older programmers use Perl, younger use Python, but it doesn't matter. You can write a task persist script in Bash if you want to. So how many of you are actually SAs instead of DBAs? Perfect, that's pretty much half what I expected, half what of the audience, which is what I expected. So this is basically the code snippet for what I meant from using the standard input and standard output. One of the first things you have to do when you work on the task persist protocol, and this is not only for this agent, but for any agent that you want to write on your own, or for any module you want to write on your own, is you have to redirect or close the standard error output. Here we use two classes. One to add all the output to the syslog, so we can still log it if there is an issue. And the second part is basically just get rid of standard error. Otherwise, the whole thing fails miserably. The code snippet number 2 is when you write one of these agents, of course, you have to use non-blocking I/O. And the reason is you cannot be waiting for the input, have the agent sitting there waiting for the input, because then there's no data collection on the back end. And this is what we use. If you're familiar with Perl, is it uses some of the I/O objects, I/O select, I believe it is, and it's pretty easy. I have the code with me on a USB stick. If not, it's published on my blog, and you can get it from there if you want to do a full inspection of the code. Or we can, on the Q&A session, we can review it a little bit in more detail. The first part of the protocol, the task persist protocol, is you have to respond with PONG, capital letters, every time you get a ping. And the reason for that is the way the SNMP module determines that your script is alive. So first thing it doesn't ping, receives a PONG, and says, okay, I can keep working with it. And then there's two commands. One is get, and the other one is set. Since the full code doesn't fit in here, every time you receive a set, basically it does nothing. It says it's not implemented, it's not nothing to write on this module, on this script. And get, then you have to supply the OID or the variable. The OID is the number you have to supply, or that the SNMP monitoring software asks you for, and of course it maps to a variable, and then you supply the value on the standard output. So this is that part of the code, and as you can see, it's extremely simple. So the line that was input is ping, you print PONG. There's no secret. It's really that simple. Since it is that simple, you can, as long as you can parse any file, you can, on the proc subsystem, you can write anything. So feel free to use this wrapper to write your own monitors. So that ends up the part that is most interesting for the SA. So who here is a DBA, MySQL DBA? So some of you are both, and that's not uncommon. So basically, what most agents do and most monitoring software do is they show you the seconds behind master. In this case, this agent gives you two chances of doing so. One is using the regular and the standard show slave status, and the other one is using the MATKit's heartbeat. So depending on which command line option you provide, it uses one or the other. However, basically the seconds behind master doesn't tell the whole story. What it does is, when you do, I don't know if you know how MySQL binary logs work, but basically every statement you apply on the master that writes to the database, let me keep doing this, it is written to the binary log, and it's written to the binary log in SQL format. And basically it has a timestamp on when was it applied on the master. As the slave applies those statements, it actually compares the timestamp with the timestamp on the slave. And it says, oh, this has been applied, 1 second later or so many seconds later. And it also calculates a little bit the timestamps that are on the queue. So after 5 minutes, you can find that actually you're like 3,600 seconds behind the master, given the right circumstances. So it's not, how come that in 10 minutes I can be so far behind when time hasn't, there wasn't that many seconds to begin with. But that is a little bit of the limitation on how it works. And heartbeat, MATKit heartbeat, what it does is actually has a table that has a timestamp and basically compares as the transactions to that table actually sneak through replication. It compares that timestamp against the current timestamp on the slave. And basically what happens in that case, it's a more realistic in terms of the time frame that you're behind, but still none of them tell you what is going on. And bytes behind master, basically what it does is it calculates how many of those transactions you have waiting, or how big are they in terms of on SQL terms. So for example, if you have a delete statement with a where clause, it might be deleting tens of thousands of records. Depending on your setting on replication, there can be just a few bytes behind, but it can set up several seconds behind. The other way of getting these offsets is you insert a blob. A blob, it will be, perhaps it will be, if you insert a number of blobs, it could be a few seconds behind, but it would be a huge amount of data behind. And it's important to know that, to know whether your slave is up to date, because if you need to promote it, or you're counting on that slave to have consistent backups or whatever other, or reporting, if you're behind, you're not, none of the things you're doing on the slave might actually have the up-to-date data. However, when you calculate bytes behind master, these binary logs are rotated. So every so many bytes, there is a parameter you can set up. It closes the current file, and it opens a new one, and it starts writing to that one. However, depending on the size of the transactions, it's actually, as soon as it passes the size that has been set up on the parameter, that it rotates. So it's not a fixed size. They vary slightly. Another thing that can happen is when you do a consistent backups, you do a flush of the logs, which will basically close the binary log to whatever size it is at that point, and then rotate them accordingly. So basically, if we look at the slave only, we don't have an idea of how big the binary logs are, and we need to go check the master to get the full information. On the master, basically what we do is show binary logs. So this is the 4 lines within slave status that we're interested in. The master log file and the read master log position means what is the latest information the slave actually retrieved from the master. And the second one, the relay master log file and the execution master log pause position is what is the position of the, what is the last transaction that has been applied to the database. So last position read from the master, and for the last write on the slave, that is where it's standing. And those are the bytes that we make a difference. Most of the time, exact master log pass would be a little bit behind, and then just doing the difference would do it in most cases. If not, we have to go look for this information on the master. And then the last line we disregard, because that's the one we already have the information on the slave status. And the other ones, as you can see, the size is slightly different. And that one, the 3073, which is the third line on that table, it shows you when a flush was done for the backups and basically rotated before it reached the 1 GB threshold. Any questions so far? So now it's going to start being a little bit more busy, all the slides. So this is the math. If we're talking, if both the relay file and the master file are the same, basically it's a simple difference. If not, we have to get the binary list from the master, and are we only one file behind? In which case, it's an easy calculation. If we're more than one, then we have to keep adding the sizes of the files that are sitting in the middle and calculate the difference between the one where we're executing and adding the current size of the binary log that we're reading from the master. So now come the code snippets. Simple case, there is some validation there to make sure that that we have the data. For example, MySQL replication has 2 threads. One is the I/O thread, which is the one pulling all the binary logs from the master, and the other one is the SQL thread, which is the one executing on the slave. And one of the things that could happen is you might have a network glitch. So at that point, you're not able to read from the master, so the master log file would actually be no results because it cannot, basically it shows no information there. If the I/O thread is okay because the network is running, but you had an inconsistent statement being executed on the slave, and that can happen many times if you're a MySQL user or DBA, you know that this happens. Then the SQL thread will be stopped, and some of the other variables actually will be the relay master log file and relay master log position will be null or empty. And well, so now to bomb, we need to do those validations. This one is more complicated because here we have to go and retrieve the information out of the master. And one of the things we did here is on the actual script, you have to provide the credentials to log in into the server you're monitoring. And we're basically requiring for this part that those same credentials actually will work on the master with the proper permissions, so you can do show binary logs. We could have used different credentials, but it would have become too complicated. One of the things we do is we don't execute this part of the code unless there's a need for it. So we're not constantly pinging the master for no reason. We only ping the master when we're behind for more than one file. That way we avoid unnecessary traffic on the master. So, any questions here to us for the bytes behind master? So there are other files, and these are actually the complicated files that need to be also kept in mind. And these depend a little bit from monitoring software and monitoring software. First of all, there is a MID file. The MID file, I can't remember now what the acronym stands for, but it has the definitions of all the numbers and what variables those numbers represent. The enterprise OID plus the identification for the MySQL variables are supplied by the INNA, and those we took straight from the original agent, so we didn't change any of that. And the other thing it does is, and then you have to add the additional suffix, which is another dot number for the variables you're using. So the bytes behind master, we added them at the end of the list, but that list is not a standard, so it may vary from software to software. Then there's 2 XML files. In our case, what we have is the part of the files that correspond to OpenNMS. And one has to do with the actual charts. So you define the charts, and the other one is with the data collection, where you define whether it's a counter or the difference between the previous value and the current value. All of that we took as it was. One of the things we had to do because of another bug on the SNMP on CentOS 5 is that the 64-bit values are rolled over onto 32 bits. That's a bug, and while we use since we use CentOS until we get to CentOS 6, which is too early to tell. For example, the RPM packages for MySQL don't work out of the box on CentOS 5, on CentOS 6. So until we kind of fix all that, and we're not going to adopt it. But until then, we divided the bytes behind master into 2 numbers. Whatever it's above 32 bits, whatever it's below 32 bits, to give us a better idea. Unfortunately, we have people that store tons of blobs on our databases, and when they do those batch loads, replication gets behind more than 32-bit counters in terms of bytes. So if you have other than OpenNMS, you can use those files. They're pretty standard, though, to adapt them to your own software. One of the things is there is reasons. One of the things that I'm not actually well behaved on following open source protocol is right now I'm only providing an RPM to download or a tarball to download. The reason is I don't want to branch it and create yet another open source project and then diversify the attention from the main project, which is MasterSense, or talking to Gerry, the knitting person. I don't know if you know her, but she wrote a Nagios plugin for MySQL that does pretty much the same. And we can wrap all of that. What we do is mostly the past persist wrapper. That's where we take our Mary. And the goal of this talk is to show you how simple it is to encourage you to do that, yourselves and enrich the other projects. But it turns out that at the end I will have to provide a way to publish it properly. The other reason I don't is I already have too many online accounts, so creating a new one on GitHub, it's not really one of the things I want to think of. The other thing is I had other projects where we use Bazaar, and we use Subversion at our company. So having to implement Git and trying to remember the commands for the 3 of them, it's just too complicated for my feeble mind. However, again, since we need to start, putting these files and make it more easier for you guys to adopt the project and contribute to it, I'll probably will have to go with someone supporting Subversion. So I will probably announce that on my blog at some point in the next month or so. So this is the line that you need to add to the SNMP configuration file. It's pretty self-explanatory if you have any experience with that particular file. Basically is you specify past persist the protocol. The OID number I was talking about is until the 20267 is .200 is the part corresponding to MySQL. The other extensions are the ones that correspond for this script. And then, let me see, yeah, the SNMP-myCNF is where the credentials are stored and additional configuration for the script. And the host is the local host, and the -R is the sampling frequency. The OpenNMS charts are charted every 5 minutes, or averaged every 5 minutes. So it doesn't make any sense to sample less than a minute apart. Most of the time you don't need sampling that is more frequent than that, so I don't recommend it. At some point what will happen is, in low traffic servers especially, you'll be starting to skew the counters, the different command counters, if you sample too frequently. And BBM is what you need to add to measure, to get the bytes behind master sampling going. All the other parameters and others are documented on the script, so it's easy to go check it out and pick it up. And master-sense documentation is very good with it. We patched it with our stuff as much as we could. Again, you're free to go and comment on my blog as it posts things about it. So, a little bit of interpretation and justification on why bytes behind master actually make sense, and showing also how beautiful these charts look like once you have them in place. So this is when you create a slave, basically what we do usually is pipe the MySQL dump from the master into the slave with the master data set to 1. So what that would do is, if you're familiar with it, is it will, MySQL dump, what it does is gets all the information off the master database in valid SQL statements that you can apply to the slave. And if you use the master data equals 1 option, it also includes 2 statements to set up the slave to the right position to where it's taking the backup. Then what we do also, since we purge the binary logs on the masters, and some of these backups can take up to a day to restore on the slave, we start the I/O thread, so the slave starts pulling all the data from the master, and we don't start the SQL thread on replication until the restore is complete. Otherwise, it will be trying to update or delete data that might not yet be there. So when that happens, the bytes behind master counters are increasing, which is that little yellow left-hand side of the period of that triangle. And but seconds behind master is null, because basically replicate the SQL thread is not running. As soon as you let it run, basically recovers, applies all the statements from the replication stream, and it goes on with its life. One of the interesting things here to see is that although it went to more than 6,000 seconds behind master at the top, it took in less than 10 minutes to recover, which is the little edges on the right-hand side of the green chart. So this is to illustrate that depending on what's going on, actually you need both variables to have a better picture of what's going on. Another example is this one. So while you apply the backup, if you use single transaction with a MySQL dump, or you do read log when you do hot backups or snapshots, while that happens, basically, in our case, it's the MySQL dump with a single transaction, the slaves start falling behind, basically because some of the tables, basically there's more I/O that has to be done, and so the MySQL slave cannot fully catch up with what's going on the master. But although it goes all the way to 10,000 seconds behind the master, we can see that when it comes to bytes, it's just a few hundred kilobytes behind, so it's not a big issue. So that's the triangle on the top with the corresponding green area on the bottom. On the other hand, we can see how, that if we have those little, 1 second, 2 second delays on the right-hand side of the chart, still means that we can be several megabytes behind at that point in time. Those are the evil blobs. And here you see what happens with batch loads. Same thing. Depending on the type of batch load you're doing, whether it's a single statement that covers multiple lines or multiple individual segments that you're inserting or modifying all at the same time, one will have peaks on the top graphic, which is seconds behind master, and won't show on the bytes behind master. The other ones will show on the bytes behind master and not show on the seconds behind master. So it helps you understand what kind of load you have on your database and how replication behaves, and then how to interpret, whether your server is healthy or not. You really need the full picture. And here's another one, and this one has to do a little bit with the one I was talking about at the beginning. Replication thread actually was interrupted there, so the seconds behind master doesn't show anymore. Does that mean everything is horribly wrong? Not really, because as we can see on the chart on the bottom, that data is still being copied onto the slave. So eventually we're going to recover, or there's not a major disaster going on. It's not the slave is completely dead, it's just struggling on the network. If you replicate overseas, and the delays, the network, depending on the network settings you have and the delays you have, this is a very common situation. That you get interruptions for a few seconds and then it recovers. And this is how your charts are going to look like. So, any questions? I'm open to review the code for those who are interested in. I Twitter with Celo Gaucho, which also includes the Bologna sandwich I ate this morning for breakfast. And how interesting was the biodiversity, the do-it-yourself bio keynote today, but references to MySQL material as well. Yes?
I'll start the flame war. Why pass persist as opposed to exec or extend?
Again, it was the simplicity of the protocol. There's no other reason than being lazy and using a simple protocol that we can easily debug, and they would work on any scenario. As we move away from CentOS 5, there would be no reason to use pass persist, but it has served us very well and more than MySQL. For example, we were testing Fusion IO cards. I don't know if you're familiar with them. They're SSD cards, and they're PCI cards as opposed to SSD drives, so they don't occupy bays, and you can easily create all kinds of cool hardware combinations with them. They're so new they don't have all the information out so writing a pass persist module to read on the prop file for the Fusion IO cards and charting, it was a 2-hour work, 3-hour work, and that's the only reason for pass persist.
And when a GET request comes in, what's the timeout? If it takes your script longer than X seconds to run, it falls over, and then what happens?
That is part of the, that is on the SNMP configuration. I can't remember now if it is on the daemon, snmpd.conf, it's one of the parameters in there, okay. Or whether it's on the monitoring software on the other side that it pulls and it doesn't respond with anything. But there is a timeout, and there are other agents that, if it's not communicating, will alarm and chart those interruptions.
I was going to say also with exec or extend, you're paying a penalty for fork every time you're doing that.
Penalty for what? I'm sorry?
You have to, SNMPD is going to fork off the process to exec that statement. So
yeah, correct.
So there's a penalty for that as opposed to pass persist where it's a long-running process.
Yeah, that's correct. When we had issues with the exec or the regular, we had to kill not only the SNMP agent, but also the actual script. In this case, it runs on demand, the script. You know, the SNMP agent in daemon doesn't actually run the script until you demand it to run. And if you kill the SNMP daemon, the script stops running. Again, there's no other reasons than simplicity.
Yeah.
One other thing is the original code for show INNODB status to get all information from INNODB, it actually uses some of the Percona patches, so some of the charts on regular MySQL don't get populated. Again, you can, although you can test and run the script interactively, and it's very convenient during development, you can also use the SNMP walk utilities to see how the information is actually presented by the SNMP daemon on the local host or in the remote monitoring host as well. So you can test. Your script is doing what it's supposed to do. The SNMPD is talking to it locally properly, and it's talking to it properly across the network, which we couldn't do with the X agent. So that's it. Cool.